My name is Camille Tucker, and today I'm going to be doing a presentation on gamma ray telescopes. Okay, first let's talk about telescope location and why this is important. As we learned about in class, gamma rays are a form of electromagnetic radiation emitted from an excited nucleus, and gamma rays are the shortest waves and therefore the highest energy on the electromagnetic spectrum. So this is important because these gamma rays are almost entirely blocked or absorbed by the Earth's sphere or atmosphere, which means that in a majority of cases, they can only be observed by telescopes in space and not on the Earth's surface. So typically these telescopes are put on high altitude balloons or satellites, basically anything that is not on Earth's surface because they need to be able to collect the gamma rays. Let's look at different types of gamma ray telescopes. The first is the Compton telescopes, and these utilize Compton scattering principles to detect gamma rays in the energy range of 1 to 3 melvins. Next, we have pair production telescopes. So at energies above 30 melvins, gamma rays can convert into electron-positron pairs upon interaction with a detector material, allowing for their detection. And then finally, we have the IACTs, and these detect Cherenkov radiation produced when gamma rays interact with Earth's atmosphere, enabling ground-based gamma ray astronomy, which is really cool because most telescopes, as I said before, are only able to get gamma rays if they're outside of Earth's surface, but this IACT telescope is actually able to detect gamma rays from Earth's surface, which is awesome. And then let's look at some gamma ray milestones. Early observations. The first detection of cosmic gamma rays occurred in the 1960s with satellites like the Explorer and OSO-3 identifying gamma ray emissions from the galactic plane. So this was pretty groundbreaking at the time. And then we have the Compton Gamma Ray Observatory from 1991 to 2000. And this mission provided comprehensive observations of the gamma ray sky, detecting numerous sources and advancing our understanding of high energy astrophysical processes. So now on to modern advancements. My personal favorite telescope that I learned about was the Fermi Gamma Ray Space Telescope. Launched in 2008, it continues to survey the gamma ray sky, contributing to discoveries about active galactic nuclei, pulsars, and gamma ray bursts. So the Fermi has been really groundbreaking and has showed astronomers a lot of things about space that we didn't know about before. And then next we have Very Energetic Radiation Imaging Telescope Array System, which is definitely a mouthful, but this is basically just a ground-based IACT array that has detected over 60 very high energy gamma ray sources, including supernova remnants and active galactic nuclei. So again, super important and amazing discoveries. And this one, similar to one of the telescopes I was talking about earlier, is also able to detect gamma rays from Earth's surface, which is something that we were not able to do before. And then we have the CTA, an upcoming next generation ground-based observatory designed to detect gamma rays with unprecedented sensitivity and resolution. Okay, I want to talk a little bit more about the Fermi because when I was doing my research on gamma ray telescopes, this definitely popped up a lot and I thought it was really interesting. So some key instruments that the Fermi uses are Large Area Telescope, or an LAT, which scans the sky for cosmic phenomena like black holes and pulsars. And then it also uses Gamma Ray Burst Monitor, or GBM, which detects powerful gamma ray bursts. As for the major discoveries that Fermi has helped us discover are gamma ray flashes from Earth's thunderstorms, gamma ray bursts linked to neutron star mergers, and also importantly, is Fermi was a global collaboration. So it's a joint effort by NASA, the US Department of Energy, and international partners. And here is a picture of the Fermi telescope. And that is the end of my presentation. Thank you for listening.